There's a lot to say about the adventure that I ended up having trying to replace this input shaft, and we'll try to condense it into this video as much as possible. First, we'll take another look at what's wrong with it. You don't need a particularly keen eye to do so though, as the last half-inch of splines have been clearly sheared off. The exact cause of this is unknown to me, and this appears to be the weak link in a chain, whether it was designed that way or not. The input shaft engages on this coupler, which is bolted to the drive gear in the front end of the supercharger. It's pretty clear that these splines don't have a ton of surface area to work with based on how shallow the engagement of the input shaft was. The damage to the coupler isn't as obvious, but is definitely still enough that it should be replaced. The problem here is that not only has B&M as a standalone company not existed since 1999, it would seem that when Holley bought them, they didn't continue the 250 line of superchargers for all that long. And while there is an input shaft set available on Holley's website, it's a different model that uses splines on both ends. I scoured the internet and made a few phone calls, but it seems like there's just no way to get one of these shafts anymore. But from our past experiences with the Y-end 144 supercharger, which is very much based on the old B&M designs, we know that its front drive parts bear a striking resemblance to those in the B&M 250. The problem is that the input shaft is just a little bit longer. This particular example is also a coarse spline layout with only 15 instead of 30 like on the fine spline models. We removed these from the 144 because the looseness in the splines was creating a bit of excess noise. It ended up being very convenient that we had these sitting around because we were able to use them to confirm that the old B&M parts are compatible with the newer Y-end parts. And other than the spline count and, of course, the obvious difference in length, they seemed like a perfect match. Taking a file to the old input shaft, it sure seems like it's made out of mild steel, and at the very least, none of it is hardened anymore. The 144 input shaft is definitely harder, but the file still marks it, and I think it's probably just a different grade of steel. At this point, it's clear that we're going to need a custom input shaft to replace the old one, but I don't really want to use the coarse spline shaft because it might just have the same rattling issue it did in the 144. So, for a better starting point, I went out and bought this set. It's only one part number off the 91180 set we used in the 144 supercharger, the only difference being that this one is a little bit shorter and I was able to find it at a better price. The set includes the input shaft itself, a new improved coupler, and a new front bearing and seal. Back when we installed the 91180 set, we found that the seal included in it was incorrect for our application. Bizarrely enough, this set included that same seal, which is correct for our 250 since it seals on the pulley coupler. Anyway, that seal is not the important part of the set. Like the old B&M ones, these are fine splined parts, although they certainly look a lot nicer. They're also a very tight fit to each other, and it took a mallet to separate them. This new input shaft seems like it's the same hardness as that coarse splined one, so it's probably a decent grade of steel, but not actually heat treated. With them laid out next to the old 144 parts, we can see that the shiny input shaft is about an inch shorter, while the coupler that came with it is half an inch longer. This taller coupler, which I assume is some revision on the design, pretty much doubles the spline engagement and should make for a much stronger connection. The spline count of 30 is also a perfect match for those old B&M parts, which raises some questions as to why there was ever a 15 spline model. Okay, whatever, I've already talked way too much about this stuff. What about actually making an input shaft to fit this thing? A smart, sane, normal person would take the input shaft we just bought and send it to a machine shop to have it shortened and a new bearing shoulder and keyway cut. Since cutting splines is a more specialized operation, that would be the cheapest and easiest way to go. Of course, that's not what I did. I thought, I can shorten this thing myself. For various reasons, I'm going to recommend against doing just about everything you'll see in the rest of this episode. If you want to skip this, I wouldn't blame you, but I felt like this trial and error process of trying to find a way to do this myself was worth including in the series. The first thing we tried was shortening that brand new 144 shaft. This will require 2 cuts, a whole lot of welding, and this tight-fitting mild steel sleeve that will go over top of the whole thing. Because it's a slip fit in the coupler, the overall length doesn't have to be incredibly precise, but we do want to get it as close as possible. The cuts were made with the angle grinder by applying a lot of pressure, but just taking a little bit each time. Not knowing for sure what the material is, I tried to be careful about putting too much heat into any one part of it. Before long, we were all the way through and now have a nice, expensive little splined stub. We'll repeat that same process to make the second cut, and pretty soon we've got our 2 pieces. The length seems about right. Other than the cut down the middle, these 2 parts are pretty much the same. To make for a nice strong connection, we'll need to cut a chamfer into each end of the shaft so that we can fill in the valley with weld. Other than spending 600 years sanding it, I didn't have a lot of ideas about how to do this, so we'll just nibble away at it with the angle grinder until we have the rough shape we're looking for. Then, in an attempt to keep everything aligned, we'll clamp it down in the vise up against a piece of angle iron. I truly cannot express how non-ideal all of this is. I was just really hoping it would work out because it would be cool to be able to say it was done this way. We'll start off with a few tack welds and try to make sure everything stays relatively cool. Here it is after those initial welds, but we can already tell it's not straight enough because it won't slide smoothly into the sleeve. We can farther test this and visualize it by rolling the shaft around on a piece of plate glass that should be very flat. From this, there is some obvious wobble, and if we can see and hear it, it is way too much. I tried straightening it, but it just wasn't happening, so we'll have to try again. This time I wanted to see if there was any noticeable wobble with the steel sleeve holding it together. And as far as I could tell, there wasn't. It was at least as straight as the old B&M shaft. So I decided it made sense that we would cut a window into the sleeve so that it could hold the shaft in line while we started to weld it. We'll drill out the 2 ends of that slot and then connect the lines with the angle grinder. It is a bit harder to tell for sure, but it seems like everything is pretty concentric. So back to welding, this time through the window in the sleeve. We'll do a little bit of cleanup and then head back to the glass, where it seems like the input shaft is pretty straight. This was followed by a bit more welding, again through the window, and it seemed like things were still going well. We continued to build up the weld, rotating the shaft a bit at a time until it was solid all the way around. Any of the weld extending beyond the 1-inch diameter of the shaft will have to be ground off since we still need that sleeve to fit over it. Once that was taken care of, this is what we were left with. And amazingly, as far as I could tell from the sound of it rolling and watching it, it sure seemed like it was still straight. But of course, that's only part of the battle. Without additional reinforcement, I am just not confident in those welds holding. So it's time for the sleeve. We'll cut a section out of it about 5/8 of an inch long that should nicely bridge the welded portion of the shaft. We'll start attaching the 2 with a few heavy tack welds. And I think that hanging that off of the vise only supported on one side is where I really went wrong. I figured that these short welds wouldn't be enough heat to distort 1 inch of solid steel, but I guess I was wrong. This spent a while up against the belt sander to make it smooth all the way around, but now we can't really roll it back and forth on the glass to get an idea of how even it is. In an attempt to find a different way to test for this, we cut the head off of a bolt and threaded it into the old input shaft, which will get chucked into the drill press. Except, well, that doesn't go quite as planned. I honestly don't know if that's wobble in the drill, the bolt, or the threads cut into the input shaft, but either way I don't think it's telling us all that much. To do things a bit differently, we'll thread a bolt that hasn't been beheaded into each input shaft and spin that with the drill press via a socket adapter. There's a bit of wobble between the socket and its drive, but that may actually be helping here, and the old B&M input shaft seems to spin pretty nicely. So what about my welded monstrosity? Well, it doesn't seem great. Between the less than perfectly balanced weight in the middle and the questionable amount of out of round, there is definitely a lot more vibration. We even went through a different test where we installed both input shafts onto a bearing and spun them in the vise, but really it's all the same thing. Eventually I decided to try again and cut the sleeve completely off of it. With that shaved down, it was now clear that the shaft itself was the problem. I found what seemed to be the flattest side and cut a chunk out of the shaft opposite it. Then, my thinking went, I could tweak it just a little at a time until it was perfect. But after a whole bunch of back and forth, it was definitely much easier to make it worse than better. When I did eventually get it in a position with a minimal amount of runout, I tried to weld it and it completely threw it out of whack again. Which is when I decided to give up. Well, give up on the welded shaft because I still had some other ideas. The next of which was just to reuse the old shaft. But how exactly? This one already spins nice and true, it's just the splines we have to worry about. Although, only the last ½ inch of splines are damaged. We're not going to be able to do anything with those, but the new coupler we have is ½ inch longer than the old one, so if we were to use it, we would have the same amount of spline engagement as the drive setup did from the factory. Because the ends of the remaining splines are flattened out from the damage, we will need to do a little bit of modification to get that coupler to slide on, and it's not pretty, but finally we are able to install the coupler. From comparing the install depth of the old coupler versus the new one, we can determine that we have 0.57 inches of splines engaged. It's actually a little bit more than factory. This would probably have worked, and worked quite well. The only concern I had left was that it might still not be enough to keep the splines from getting sheared off sometime in the future. After thinking about it for a while, I got a crazy idea in my head, and for some reason, actually went and did it. The first step is to drill out the center of the shaft to beyond the damaged splines. Then we'll proceed to cut off the entirety of that damaged area. We'll drill down to 0.9 inches and use a tap to cut in threads. And after some time at the disc sander, we have a nice squared off end. Other than being shorter than it originally was, it actually looks pretty good. But why do all that? Well, the idea is that we're going to take the end off of this other shaft and bolt it to the shorter one. We could weld that extension on, but after the previous warpage issues, I was a bit concerned about revisiting them. Regardless of the method of attachment, this two-piece shaft was never going to be anywhere close to as strong as a solid one, but I figured if we could add 5 or 10% more strength, it might be enough to keep the splines intact long term. The bolt we beheaded earlier will get cut to length and threaded into the shortened input shaft. We'll slide the spline extension over that, and the coupler will keep everything lined up. We'll get the extension about halfway filled up with weld on one pass to make sure the bolt got hot enough to melt together with everything else. We'll get everything cooled down and remove the coupler before doing one more pass of welding. The thinking is that if the splines ever did start to slip, it would be tightening the bolt in that extension and hopefully add just a little bit more for the coupler to push against. To make sure they really hold together, we'll apply some red Loctite and tighten down the input shaft onto the extension. This is where I got myself into trouble. Yeah, by tightening this an extra 1/30th of a turn, it no longer fit into the coupler. I was able to tap the coupler onto it, but it was definitely not the same fit it was before. And from there, it never got better. I think hammering it into the coupler kind of just recut the splines on the actual input shaft just a little bit crooked so that they were in line with the extension. And redoing some of the input shaft spin testing, you can see that the coupler has just a little bit of wobble to it. It's minor enough that it was hard to see with the naked eye, but it is definitely there. With the very high RPMs the Supercharger needs to be able to spin at, the best case scenario here is that it would wear out the bearings faster. And that just kinda sucks. It was a hell of an experience trying to make something that would work, and I feel like I did learn a lot. Sure, most of that learning was through mistakes, but those are the lessons that seem to stick around the most. We basically came out of this with a mock-up for the part that we need, but not one that I would actually feel good about using. So, once again, we need a different approach. I had been trying to find a way to modify this old 144 input shaft that we already had on hand, and after contacting a dozen machine shops, I finally had a plan. I had been reaching out to shops that make custom CV axles because that means they have spline cutting equipment, and the first one that got back to me quoted $600 and would only make a new part. For less than that, I could pick up another Y-end input shaft and have a more common machine shop modify the bearing end of it, which was looking like the only option until I found Brannick Motorsports out of Indiana. They gave a quote of about $250 in machine time to modify this part, and that seemed like it was worth a try. Before we ship it out, and to save them a little bit of time, we'll go ahead and cut the shaft to length here. Like with the other cuts, we'll take a few breaks to let everything cool down and make sure we don't overheat the steel. Once we're left with two separate pieces, we'll use the disc sander to square off the cut on the piece that will eventually become our new input shaft. We'll follow that up with a minor chamfer on the outer edge, which leaves us with this blank. Well, half of a blank since it does already have one side finished. We'll mail out the shaft blank, the bolt together shaft for reference, and the coupler so that they can make everything fit together nicely. The parts were sent out in May of 2020, which was, to say the least, a difficult time. So it wasn't exactly surprising that it took them 2 months to get the work done and mail the parts back, but the day has finally come. The total cost, including shipping, was much less than expected at only $90. But how good do those splines look, and how well do they fit? They certainly appear to be nicely machined, though maybe could be a tighter fit in the coupler. For comparison, here's the coarse splined pair that we took out of the 144, and the factory thought was good enough to send out the door. Our custom cut shaft has a fair bit less play than that one, so I don't imagine it'll be enough to cause problems, and overall, especially for the price, I'm pretty happy with the results. Whether you'd call it frugality, pride, or stubbornness, I really like doing as much of this work as possible myself. But after all those failed attempts at making one, it was clear that this part was out of my league, so I'm very thankful to Brannick Motorsports for making this happen. We finally have an input shaft that's the right length and hasn't been welded or bolted together. But, perhaps unsurprisingly, I'm not done messing with it. There's one more connection to the input shaft that I would like to shore up. Once everything's assembled, the only things keeping the pulley coupler from spinning on the input shaft are friction and this little square steel key. That little guy takes on the majority of the load, and I've heard with these 250 blowers can be a point of failure. So in order to spread out that load, we're going to give it a friend. But I don't have the equipment or expertise to add another square keyway, so we're going to be drilling it out and dropping in a pin. We'll be drilling to just over an inch in depth, and these 3 washers on the drill bit will keep it from going too far. Considering the equipment and operator, this was never going to be incredibly high precision, but as long as the pin is a nice tight fit, it shouldn't really matter. We're using a 7/32 of an inch drill bit, and we will make a pin to match. I keep a lot of dull and broken drill bits around because they are perfect for little things like this. We'll cut an inch-long section out of this 7/32 of an inch high-speed steel drill bit, which will make a perfect dowel pin. With that cut off, we'll use the disc sander to knock it down to exactly 1 inch in length. We won't be going through the assembly process in this video, but we can jump forward a little bit to show you how the key and dowel pin will look once installed between the input shaft and the coupler. That should make for a stronger connection between the parts, regardless of whether or not it was actually necessary. I can't say the process of sorting out this input shaft situation was easy or fun, and neither was putting this video together. But sometimes plans don't work out, and I thought this was an important part of this whole rebuild procedure we're going through, so I didn't want to skip over it. Make no mistake, we're not done fumbling through that process, and there are plenty of problems ahead of us.
Oh shit.
Though at least we have checked one more thing off of the list.